Hello, everyone, and welcome to our session taking a look at the life cycle assessment of products with a focus on carbon footprint. As sustainability becomes more and more important in industry and society, companies must focus on the carbon footprint of not only their own production, but also their suppliers and partners. I'm pleased to introduce Jyrker Chile from Volvo Construction Equipment in Sweden, a veteran in supplier development, to speak to you today about this. And with that, I will hand it over to Jyrker.
Thank you very much, Zach, and thank you for having me here. So I guess you see my screen now. I will start to talk a little bit about Volvo Construction Equipment journey through life cycle assessment. One of our first steps for decarbonization of the value chain. So about me, my name is Jyrker Chile. I'm Senior Supply Development Engineer at Volvo. This role is part of purchasing. I work with supplier evaluations for new and existing suppliers. We do supplier audits within areas of quality, capacity, and also sustainability. Within our team, we do also specific index audits like cleanliness, paint, welding, and so on. So for the last 8 years, I've been working on developing our Volvo CE electromobility supply base. For me, supplier relationship should be a collaboration. It's important that we win together. The better supplier we have, that will be. So it's important to have a good collaboration. I have a Master of Science in Mechanical Engineering. I also have a previous experience, 10 years spending as engineer for HVAC system, heating, ventilation, and air conditioning for Volvo and Scania trucks. So in this presentation, I will talk a little bit about Volvo Group and Volvo Construction Equipment, which is part of Volvo Group, small company presentation. I will talk about our sustainability targets and ambitions. And this is the reason why we started to focus on doing life cycle analysis on our carbon footprint. So I will talk about our method, how we collect and present LCA data, some of the challenges that this impose, some practical details on our chosen approach, also some pitfalls and recommendation, and what will be the next step, analysis and reduction of our footprint. So first, Volvo Group. We have 10 strong brands under one roof, 3 truck brands, Renault Truck, Mack Trucks, and Volvo Trucks. Then we have Volvo Construction Equipment. We produce wheel loaders, excavators, articulator, and rigid dump trucks, among other things. Then we have Volvo Buses, which produce buses. Penta for marine application and also genset equipment. Then I'm happy to introduce also Volvo Energy since 2022, a new business area that will take care about battery business, new and second life of batteries, charging solutions, energy storage, battery life cycle management. We are building a new battery cell manufacturing in Mariefred, Sweden, within this business area. Then we have Volvo Autonomous Solutions, which were introduced in 2020. They develop autonomous solutions to all our vehicles with the aim of improved safety and productivity. Arcus is our defense brand, and Volvo Financial Services is helping our customers finance their purchase of machines and vehicles. So to summarize Volvo Group, we make products to transport people and material, both on land and water. We have a clear environmental focus through electrification and autonomy. We build the world we would like to live in. So a little bit specific on Volvo Construction Equipment. This is our global footprint. We have manufacturing and R&D all over the world. Some sites is Shippensburg, US, Cons, Germany, Belay in France, Motherwell, UK, Bangalore, India, Changwon, Korea, Linyi in China. We also have manufacturing plant in Brazil. In Sweden, we have multiple locations. Eskilstuna, Sweden, where I am, we do axles and transmission that we supply to our plants in Arvika and Borås. And we have a cab plant in Hallsberg. And from last year, I'm happy to say that we have now our headquarters back in Eskilstuna, and this is actually where it all started many, many years ago. So our machines are assembled in 9 countries. We are present in over 180 markets. Volvo Construction Equipment employs more than 15,000 people. Maybe not so much for a global company, but since we're part of a global group of over 100,000 employees, that's quite good. So our sustainability targets and ambition. Volvo Group has committed to the Science Based Targets initiative already in 2020. And we got our targets validated by this Science Based Targets initiative. So that means that we will be a net zero emission company by 2050. So in order to reach this, Volvo CE has set some interim targets. And we have set them already for 2030. We will be reducing our carbon dioxide emissions from our own operations by 50%. And we will reduce the carbon dioxide emissions from our products in use by 30%. And this is going to be reached already by 2030. And that is, as you know, only 6 years from now. And in order to do so, we need to have 35% electric vehicles by 2030. And for us, that's a big challenge because we have more than 250 different machine models. So in order to achieve this, we need to continue our industry-leading profitability. We will doubling our revenues from services. We're aiming at 35% female employees and leaders. And of course, we need 100% employee involvement. 35% female employees might not sound that impressive, but in our business, unfortunately, this is a stretch target. So our science-based target initiatives demands that our business is carbon neutral by 2050, but we need to actually become carbon neutral already by 2040. So why is that? It's because our machines that we sell 2040 will have an average life length of 10 years. So during those 10 years, the machines will release carbon dioxide in use. So that means we need to be carbon neutral 10 years ahead of the target. So what will it look like? This is our journey towards net zero emissions. Today, we have almost 100% combustion engine, diesel-driven machines. And by 2030, we already said that we'll have 35% electric vehicles. And we are aiming at battery electric, fuel cell electric, and also run some machines on alternative fuels. This is the way we're going to reach our targets. We see many benefits of electrification. An electric machine can achieve 0 carbon emissions. Electric machine is much more efficient. I believe that an electric machine can be up to 95% efficient or more, while a diesel engine can only reach like 35. Electric machine is very quiet. That means it can work through the night without causing disturbances in urban areas. And this can improve the productivity of the machine. An electric machine is emission-free. That means that we can work with these machines in closed areas, for example, parking garage, mining application, and so on. Also, we believe that an electric machine, even if it's much more expensive to buy, at least now in the beginning, we can have an improved cost of ownership over the lifetime of the machine. Okay, so how can we calculate our impact, carbon dioxide impact from our machines? First of all, we need to look at the entire value chain, all the way from extraction, process, design, manufacture, use, distribution, repair, disposal, and so on. That means that we need to add the carbon dioxide emissions from raw material usage at the first tier suppliers. Then we add the first tier suppliers' production. That is scope 1, 2, and 3.3. And I will in next slide present a little bit more what I mean by the scopes. This is general. Then we need to add the logistics. And that means how we transport the goods from our suppliers to our production plant. Then we have emissions from our in-house production and assembly. Then we need to add emissions from logistics when we sell the machine. So that means transport of the machine to our customer. Then we need to add the total fuel consumption at our customer. And as I already mentioned, we are calculating 10 years average use of our machine. Then we add standard service and maintenance of the machine, also for 10 years. And at the end of this, emissions for end of life and recycling of the machine. All this adds to the total carbon dioxide emissions per product. So generally, historically, we have calculated our in-house emissions and emissions from use, but it's quite hard to calculate the contribution from our suppliers and also from raw material. So this is what we have developed a template for. So, but what do we mean by the different scope? Scope 1 is direct emissions from the reporting company. So that comes from our company facilities and company vehicles. Scope 2 is indirect emissions. That comes from purchased electricity, steam, heating, cooling, and so on, upstream. Then we have scope 3, which is indirect, both upstream and downstream activities. And this could be purchased goods and services, capital goods, fuel and energy related activities, transportation and distribution, waste generated in operations, business travel, commuting, and leased assets. Then we have downstream activities like transportation and distribution, processing of sold products, use of sold products, end-of-life treatment of sold products, leased assets, franchise, and investments. So when we say life cycle assessment, we mean cradle to grave, and we include production, manufacturing, use phase, and recycling. So this is a linear divide of the product's life cycle. So Volvo's part of this is gate to gate. That's our in-house production. Before our gate is supplier emissions, logistics to our factory, raw material extraction, and process to manufacture the material. And the entire production and manufacturing is called cradle to gate. Then we have well to wheel. And what we normally don't think about is that to produce the fuel for our machines, we actually consume energy. And this energy means that we are emitting emissions. And then when we put the fuel in our machines, of course, we all emissions. Tank to wheel. Then we have recycling, end of life. So LCA is a standardized tool for collecting data and describing a product's environmental impact throughout its life cycle. The focus has been gate to gate because it's easy to measure, but we are considering the entire value chain. So, some background to our LCA program. We started in 2019. And in order to collect data from our suppliers, we developed our own LCA template called Supplier Carbon Footprint Questionnaire. And this is to break down company level carbon dioxide emissions to the part number, the parts that we are buying. This summarizes the greenhouse gases from each of the life cycle steps of the products. And why do we do this? Well, we can see that this is started to be demanded by our customers. Our customers that are buying a machine, they need to, in their turn, be able to state how much carbon dioxide they are emitting in order to win their tenders. And of course, when we gather this data, it is an as-is investigation, and all improvement work starts with measuring. So this is the first step. This also helps our supplier to improve, reduce their greenhouse gas emissions by, first of all, find out where they comes from. You can reduce your energy cost. You can reduce the risk of the supply chain. And of course, doing this means learning from each other. We learn from our suppliers and their suppliers can learn from us. Then there's a competitive advantage also. By disclosing your greenhouse gas performance, you can strengthen your brand image and your reputation. That means both for us and our suppliers. So collecting LCA data is quite challenging. First of all, for construction equipment, there is no product category in the GHG protocol, greenhouse gas protocol. So that means that we need to follow a general standard called Product Life Cycling Accounting and Reporting Standard. And there is room for interpretation in this standard. This means that if we are making a report of our carbon footprint, it's not directly comparable to our competitors' report. And the reason for that is there is difference in methodology, there is different in system boundaries, there's different in input data, and also the way that we collect the data. So that means that an LCA completed by 10 different parties could mean 10 different results. But the different reports that we do on our machines are comparable between our machines because we are using the same methods. And of course, it takes some hard work, so there will be some costs involved as well. The reports that we produce are based on global standards. Those are the ISO standard for life cycle assessment, 14040/44 2006, and the Greenhouse Gas Protocol. This approach covers consequently all steps in the value chain from raw material to product end of use. So that means cradle to grave. There is also some exceptions. And as mentioned, we do follow the standards, but some of the emissions are not covered. And that is packaging materials used for inbound logistics, impact from recycling process for all residual material except aluminum and steel. But our machine, if you look at the weight of the machine, aluminum and steel is basically 80-90% of the machine. So the rest, which is not covered, is not a big portion. Waste and wastewater treatment is not considered. Personnel related travels, that means business travel, commuting, personnel traveling at the site is not included. Unplanned machine repair maintenance is not covered, but planned maintenance is included. and then solvents from surface coating in-house at Volvo Construction Equipment. So, some practical approach. How did we do this? This is a manual data collection, and we decided to use our contacts that we already have, contact surfaces. So, in order to collect data for one machine type, we start with a bill of material. And the bill of material contains all the parts that the machine is made up of. And all the parts are delivered by different suppliers. And of course, some suppliers deliver several parts. Each supplier have contact persons. In our case, it could be buyers, commodity managers, supply development engineers like myself, supplier host, and so on. So we define one contact person per each supplier. That contact person sends out manually the request, that means this template, to the customer contact person. And this could also be different persons that will receive this. And they need to find in their turn at the customer, at the supplier, who can provide this information that we request. Then this should be sent back to us, and we populate our bill of material with all the data that we collect and summarize it. So since 2019, over 600 suppliers have contributed to this investigation. The best response rate that we had was under 24. The worst were more than 6 months. 80 to 90% is the average response rate in general. And that's quite good because we have suppliers all over the world. So you can imagine that some suppliers, they are probably ahead of us, and some suppliers, they are behind and don't understand what LCA is or means at all. So in those cases, we need to spend a little bit more time to convince them. Great thing to see is that many suppliers have started their own LCA programs, and they are using, in some case, our own template. And we encourage that. That's great. So far, we had no system support. It's only hard work in Excel. And this is the key success factor for us to be quick to market with disclosing this data. So looking at the templates, what do we require? There is 3 alternatives way of reporting. First, if you as a supply partner already have environmental product declaration, that means a complete LCA report for a product approved by third party. This is accepted by us. Then all the data is already available. The second alternative is a self-declaration, which is similar to the first option, but maybe it doesn't follow standard and is not independently verified. But we do accept that as well. The third and most common option is that the supplier is using our LCA templates provided by us. Then they state their energy resources used and greenhouse gas emissions per product plant, and then we divide that by the part number that we are buying. Then we have to have also information about type of raw material for this part, gross weight, and country of origin. And gross weight, that means also waste when producing the part and other. So it's not net weight, it's gross weight. This is the most common alternative. So step 1, define the total footprint per production site. That means maybe you know your scope 1, 2, and 3.3 emissions. Then you can state it. Otherwise, you need to bring your invoices. So that means summarize per year all used energy in your production plant. Maybe you have several plants, then you have to collect all the production plants for that part number. But usually it's one production plant. And what we're looking for is your total use of district heating, diesel, HVO, electricity, different gas, heating oil, petrol, steam, and others. Second step is to divide this complete amount of energy use and allocate that from factory level to part level. And then we have three methods that we accept. The first one is mass allocation by weight. And that could be suitable for components where you have maybe like foundry, plastic manufacturing, and so on. Then you can do volume allocation by production time. Maybe for assembly intensive parts where the production time is what is defining the energy use. Glue operation, things like this. The third option is volume allocation per production unit. Maybe most suitable for screws, brackets, small similar size parts. So in this case, it's up to the supplier to choose how you divide your energy use per part. So we ask the supplier to be smart and honest. Maybe you can think about what can you easily measure? Can you easily measure the part weight? Do you easily measure production time? Do you easily measure amount of units you produce? And what makes the most honest results? Then we need to add emissions from material content. So for each part number, we ask supplier to categorize each part. And the different categories are, for example, PCB, printed circuit boards, bronze, copper, aluminum, steel, glass, polymer, and so on. Then we need gross weight. And gross weight means part weight plus scrap and waste in production, because also the waste will contribute to emissions. Then we need country of origin. And why do we need that? It's because emission from material content varies depending on where in the world you have this. So when we have put all this together, we have got all the results from the supplier. We can crunch the numbers, and the results will be presented in the next slide. This is one example. This is a 15-ton wheeled excavator, and what we can see here is that during the use of the machine, this machine will emit 325,000 kilos of carbon dioxide equivalents, cradle to grave. So that means from material, through manufacturing, through use, all the way to recycling or end of life. So 74%, what is that? This is from the user phase, and we calculate that based on environmental class 1 diesel, which emits 3.3 kilo carbon dioxide per liter. And we estimate the lifetime to 10 years. We collect from our CareTrack telematics system average usage per year and average energy use per hour. And by calculating that, see that 74% of these emissions comes from the user phase. 4% is from our suppliers, scope 1, 2, and 3. And interesting to see here, we need to apply the Pareto principle, the 80-20 rule, because 20% of the components in our machine make up 80% of the cost. And those 20% of the component also make up 90% of the weight of the machine. So for us, it doesn't make sense to ask our suppliers for 100% of the parts. We can focus on only 20%, And then we extrapolate up to 100% to get this number. Then we have the last 19%, which comes from material. And as mentioned before, we are using EPD, environmental product data, which is a standardized environmental data per material, or we use the Gabi LCA database to calculate this. And we're using gross weight, which includes scrap and waste. So I'm happy to say that Volvo Construction Equipment was the first construction equipment manufacturer to publish carbon footprint information for a complete machine externally. And today we have LCA completed for most of our machines. All our customers can find these reports on Volvo Group homepage. Everybody can download it. And it looks like this. It's 2 pages for each machine. A little bit information about how we have collected this data, some of our definitions. And then on the second page, we have the data for each machine. And the first columns is emissions from our production. It's a fixed number per machine. And then it's emission during use. And it's possible to see per hour. So that means if you're a customer and you're buying this machine, you can calculate how much emissions you have already wasted while producing the machine. Then you can calculate based on your user case, how many hours will I use it for this project, or how many hours will I use it before I sell it? And then you can add or multiply that with the emissions during use, and you can put this number in your tender and disclose this to your customers. That means that a customer can easily understand the background to the calculation and can easily make your own emission calculation. Another interesting example from compact equipment, and this is a key takeaway. Electrification is the key enabler to lower our carbon footprint, and it's also the quickest way to lower the emissions. And I will demonstrate that by looking at pie charts. Emissions cradle to grave for this compact machine if it's driven by a diesel engine. We can see that material content contributes to 19% of the emissions. Then you have supplier production, which is 4% only, and the fuel used during 10 years stands for 74% of the emissions. So what happens if we electrify this machine? Well, we can fuel the machine by EU mix electricity, which is a mix and contains not maybe the best electricity. Then we can see that raw material increases mainly due to that we need to have a battery in the machine. And fuel contribution to emissions decreases a lot. Now it's only 28%. Supplier production increases to 12, but it's actually not an increase because this is proportional. So it's important to think that this is proportional to the previous one. So it means it's not actually an increase, but it becomes increasingly more important. So what happens if we, instead of the EU mix, is fueling this electric machine with renewable electricity? Then we are down to 5% during the user phase. And the raw material, including battery, stands for 70% of the emission, and supplier production is 17%. So raw materials is obviously the next step. So what can we do with raw material? Maybe some other speaker can talk about this, or I can come back next year to talk about this. But obviously we can start to think more linear, less linear, and move to more circular economy. One way could be to use the 9R framework, try to reduce, reuse, repair, refurbish our machine, remanufacture our machine, repurpose the material used, of course, recycle and recover, which we would normally do already today. So it means that already in the R&D stage, we need to start thinking about how we can reduce the emissions. So it means we rely on our supply partners and customers to move in the same direction as us to be able to decarbonize our supply chain. So we build the world we would like to live in. Thank you very much for listening to this presentation. I hope it has been inspiring for you. And I guess we are opening up in case there are some questions.
Yeah, thank you very much, Jyrker. It was a very, very informative presentation there. So I guess I'll start with a kind of a general question. So you mentioned that Volvo is the forefront of this effort and this movement within the industrial sector, at least. So if a company was starting to go down this path of assessing their carbon footprint, maybe could you share some lessons learned as you've seen them over the years?
Yeah, I think first of all, it's quite hard work to send out this manually. So I hope that in the future there will be some system. Maybe this is already available for companies to do this. We already have systems to collect material data, for example, which is commercially and readily available. So I see that hopefully this will be, the next step to simplify a little bit how this should be done. But for us in 2019, this is almost 5 years ago now, our target was to be really quick and collect the data and rather do this in a pragmatic way, gathering the data that we could gather and follow the standards rather than doing, spending several years on developing some kind of perfect system.
Yeah, good. So the next question here from the audience is, so how does this process help you with supplier selection? How does this inform your supplier selection process?
Actually, right now we have started to gather the data. We are not using this data in supplier selection. But of course, I mean, we have our targets. We have interim targets. So in a very near future, we need to start considering this data also for future supplier selection.
So there's two questions here. I may try to combine them a bit. So looking at your data on the cradle to grave, the comparisons between the combustion vehicles and the electric vehicles, do you have any specific numbers that you'd be able to share as a comparison between the two?
Yes, there are specific numbers. And as I mentioned, I think you mean the slide where I had the 3 different pie charts.
Correct.
And there is actually numbers if you select one specific machine, and that number, of course, is depending on how you're using the machine. And when we compiled these pie charts, we took the average user case for this machine, and we used the average for each pie chart. So, and the number, if you have a user case your own, you can download this LCA report from the Volvo Group homepage. And if you know how many hours you use the machine, for how long time, and you can just multiply that with the emissions that the machine will emit, and then you add the manufacturing phase, and you have the answer. So I didn't take the specific numbers on that slide, but on the previous slide, you could see the number for the 15-ton excavator. So, and in that case, a general user case, you could see it was 325,000 kilo carbon dioxide emissions.
Okay. What about the as companies move through this and move towards this net zero commitment, what do you see as some of the biggest challenges?
I think for Volvo, we could directly see that our biggest emissions comes from the user phase, and that's why we are really, really trying to speed up the electrification. That's the first step, and that's our main target. Then, I mean, as mentioned in the presentation, we see that when we manage that, the next step will be our suppliers and the contribution from raw material. Of course, we cannot sit and wait until 2040. We need to start working on that already by now. But I cannot say, in which areas we will focus first on that section. But electrification is for sure the biggest contributor, and also something that gives a very quick result.
The next question here, maybe switching gears a little bit, is focused on batteries and battery suppliers. So has Volvo experienced issues on battery suppliers and its inherent opportunities producing them? And if so, how is Volvo helping on this topic?
I'm sorry, but batteries is not my area. Actually, I work mainly with electric motors, inverters, and other components in the electromobility, but not with batteries. So sorry, cannot answer on that one.
Okay. Next question here. First, a bit of praise from the audience here in this question. So thank you
Thank
very
you.
much. So how did Volvo convince skeptical suppliers to contribute and share data needed and dedicate resources to collect this requested data?
Yeah, actually, since we've been working with basically face-to-face contacts, I mean, in our case, USAC is my main contact person actually. So if I would send out this to you and you would be reluctant, I had to personally contact you and set up a meeting with you. Then we have a core staff within our purchasing department that has a lot of knowledge about this, which has also developed this method of collecting the data, and they are very supportive for each of the supplier. So whenever I face a problem as representative from Volvo with any of my suppliers, I can set up a call and we can explain the purpose. I know that some suppliers are reluctant to give out the information because they feel that this could be mishandled in some way, but we have confidential agreement written, and we're not using the data in any way other than collecting it. And once we're collecting it, it's completely non-traceable for anybody. So when we explain this and what the purpose is, basically 80 to 90% of our suppliers they have worked with us and have been able to disclose data on a level which has been acceptable for us.
Okay, very good. That looks like the last question here from the chat. Jurka, maybe I'll give you a second to address anything else. And if not, we will go ahead and close the broadcast here. Thank you everyone for joining. I think Jurka, it's been very informative for everybody on the call here. And don't forget, you can access your next session through the lobby. Thank you very much.
Yes. And if there is any other questions, I'm available on LinkedIn. I have a quite unusual name, so I should be fairly easy to find. And I'm happy to discuss further.
All right. Thank you very much, everyone.
Thank you.